On to the next section of mechanics, we're going to look at Newton's laws of motion. Newton's first law of motion. This states that the velocity of an object will not change unless there is a resultant force acting upon it. So what does this mean? Well, it means that if the object is stationary, then it will continue to be stationary, and that if it's moving with a particular velocity, it will continue to move with the same velocity, as long as there is no resultant force acting upon it. In the example shown below, a man holds up a set of weights. They are stationary in the air, so their velocity isn't changing. This means that the force of gravity acting downwards must be equal to the force with which the man is pushing upwards, so that there is no resultant force. Newton's second law of motion. This states that the acceleration of an object is proportional to the resultant force acting upon it. In other words, if we double the force acting on it, then we double the acceleration. And it's from this law of motion that we derive the equation force is equal to mass multiplied by acceleration. Galileo had something to say about this too. He said that all objects will fall at the same rate, which is true if you ignore air resistance, and Newton's second law of motion explains why this is the case. Newton's third law of motion. This states that each force has an equal and opposite reaction force. It's important to note that the forces are always of the same type, so the reaction force will always be of the same type as the initial force. Let's look at the following examples. In the first picture, the gravitational force exerted by the Earth on the satellite is equal and opposite to the gravitational force exerted by the satellite on the Earth. In the second picture, the push force exerted by the man on the wall is equal and opposite to the push force exerted by the wall on the man. Let's look at drag and terminal velocity. To understand this, we need to understand what friction is, and friction is a force that opposes motion. We have two types of friction. Firstly, contact friction, which happens between two solid surfaces. And then there is fluid friction, sometimes referred to as drag, which happens in a liquid or a gas, for example, air resistance. The terminal velocity happens when the friction force becomes equal to the driving force. Because these forces are in opposite directions, when their sizes become the same, there is no resultant force. This means there's no further acceleration and terminal velocity is reached. If we want to represent this graphically, we can see by plotting a velocity time graph that the velocity tails off over time until terminal velocity is reached. If we look at the velocity time graph for a man on a parachute, between A and C, the acceleration decreases as air resistance increases. At C, the force of the air resistance becomes equal to the force of gravity and terminal velocity is reached. At point D, the man opens his parachute, which increases the air resistance, so he decelerates and reaches a new lower terminal velocity, which is marked E. And if we want to represent terminal velocity on a graph and look at the acceleration, this is what it looks like, with the acceleration decreasing as time increases. And that concludes this section of mechanics.
Created using Powtoon.